Hello there, this is Wellington with PX5, and today I'll present the Pthread Lifecycle using PX5 RTOS. There are different types of APIs available with PX5 RTOS to help manage Pthread's lifecycle: the Pthread create, join, detach, cancel type, among others. I'll walk you through each one and I'll show you some demos to make it easier to understand. We can't do much without having a pthread to begin with, so the pthread create is the first API we'll explore. Creating a thread requires the familiar pthread header and then a call to the pthread create API, providing first a pointer to the thread handle, an optional pointer to thread attributes, or null if you don't need any, then the thread entry function, or the function which will be called when this thread executes, and then optionally any arguments required by that function, null otherwise. If we take a closer look at the pthread create API, we'll see that only two elements are required from the application developer to create a thread: the thread handle and the entry function. This is really much simpler than most RTOS thread and task creation APIs, which require more parameters and make it more complex. And since PX5 RTOS is using a native pthread implementation based on POSIX pthread standards, this will look very familiar to any developer creating embedded Linux applications. By default, threads are created as joinable, meaning that another thread can wait for this thread to complete. All joinable threads should use the pthread exit when their processing is complete, and either be joined via pthread joined or detached via pthread detach APIs. Failure to do so can leave the thread in a perpetual terminated state, with all of its resources allocated, both the internal thread control and the stack. Let's see a demo. Right now, main is running and creating variables, thread handles in the memory area. Now, in line 16, we have the platform setup, where hardware is initialized using vendor hardware abstraction layer. Now, we start PX5 RTOS by providing a random number for pointer data verification, a memory area, and the size of that memory area. This will convert main into the first system thread running at the default priority of PX5 RTOS, or 16. And next, we need to create another thread, the child thread. And to do that, all we need to provide is a handle to the new thread and the entry point for that thread. Here we can see that the child thread has been created with the default priority, so same as main, which is now ready and waiting to run. Main is still running. See, we're now on line 16, and it will increment its counter variable. Counter variable has been incremented, and after doing that, main will yield to allow child thread to run. Child thread is now running, and it will increment its own counter. Child thread will now yield back to main. Now it's main's turn to increment its counter. Main will now yield back to child thread, and this will go on and on. So this is the pthread create sample. That's pretty straightforward, right? So next, let's take a look at the pthread join API. And this service will suspend the currently running thread until the specified thread completes its processing. This will make this thread to wait for another thread completion. All joinable threads that complete should either be joined or detached via the pthread join or pthread detach API. It's important to notice that only one thread is allowed to join another thread. Any additional join request will return an error. Please also notice that when the specified thread exits, it might return values if a non-null destination pointer has been provided. Let's take a look at a demo. So as always, main will start executing and creating variables, thread handles in the memory area. Then we start PX5 RTOS. Now we're calling the Memory Manager Enable API to switch from the default memory management to dynamic. This will convert this memory area into a memory pool. There you go. Now we have here a memory pool, and next we'll create another thread, the child thread. So now we have the child thread created, and also notice that we do have here in the memory pool the thread stack and the thread control block. And next, main will make a call to the Pthread join API. By calling Pthread join, now main is blocked, allowing child thread to run. So child thread now will increment its counter, as you can see here, and now it will return, which, as you can see here, which will call Pthread exit implicitly. We could have called Pthread exit directly here as well. As soon as child thread returns, and since we're using dynamic memory management, all of its resources should be released. As you can see now, we don't have child thread anymore, and all of its resources have been released. At this point, the child thread execution is complete. Now let's take a look at the Pthread detach API. This service will place the specified thread in a detached state, such that it can be joined in the future. It is the equivalent of creating the thread with the Pthread create detached attribute. When the specified detached thread exits or returns, all of its resources are immediately released. Notice that a thread may call Pthread detach on itself. Let's see a demo. We'll start PX5 RTOS, and then we have here the memory area created. Next, we're making this memory area into a memory pool by calling the memory manager enable. And next, we'll create another thread, the child thread. Here we can see we have child thread created and all of its objects within the memory. And at this point, we'll detach the child thread by calling Pthread detach API. We could also have created the child thread in a detached state using attributes. So child thread has been detached. This information we can't really show here, but it lives within the thread control block. And at this point, main will yield, allowing child thread to run. Child thread is now running and will increment its counter. Now this thread returns, which will call Pthread exit implicitly. We could also have called Pthread exit directly here as well. And as soon as this thread returns, all of its resources should be released, since this is in a detached state. As you can see here, now we're back to main and there's nothing else on the memory pool, and the child thread is gone. Lastly, let's take a look at the use of Pthread create and asynchronous cancel. This service sets the calling thread's cancel type as specified in new type. If old type is non-null, then the previous cancel type is stored in the specified destination. By default, threads are created with the cancel type of Pthread cancel deferred. Let's see a demo. As we did before, we'll start PX5 RTOS, change it to dynamic memory management, which will transform this memory area into a memory pool. Then we'll create another thread, and then we'll detach this child thread, and we're gonna be yielding to child thread now. Okay, so now as you can see, child thread will enable asynchronous or immediate cancellation of this thread. We'll increment the counter and yield back to main, and we can make a call to the Pthread cancel API and cancel the child thread, which is done immediately since it enabled asynchronous cancellation. And now we don't have a second thread or its memory objects anymore. So in this video, we took a look at the Pthread create, detach, join, and we look at the cancel type, which we believe will help you manage threads in your application. That's the demo we had for today. As always, if you want to get started or learn more, make sure to check our website at px5rtos.com. You can email us or call us with questions, requests for information, or a quote at info@px5rtos.com. Thank you for your interest.